so today's lesson is on the circle and the equation of a circle. I'm just going to go over the investigation really briefly to make sure everyone got the right answer. But before we actually get to the equation, just a few recap definitions. The radius is the distance from the center of the circle to a point on the circle. Okay, so that's half of the entire width of the circle. If you go from one end to the other, that's the diameter, and the diameter is double the radius. Okay, their circumference is pretty much the perimeter of the circle, and any single point on the circumference of the circle is equidistant from the center. So the distance is the same from the center to any point on the outside of that circle. Okay, so when you had the circle x squared plus y squared equals 4, you should have noticed that the center was 0, 0. In fact, for any single equation x squared plus y squared equals something, you should have noticed that the center was 0, 0 in all of those scenarios. Now, for that first red circle, the radius you should have noticed from the center to the outside would have been positive 2. For the next one, when it's x squared plus y squared equals 16, you should have noticed the radius was 4. When the number was equal to 25, the radius was 5. When it was 64, that number was 8. Now the connection you should have seen here is if you square root that number to the right of the equal sign, you're going to get the radius of your circle. So the square root of 4 is 2. The square root of 16 is 4. The square root of 25 is 5. The square root of 64 is 8. Without even graphing, if you saw the equation x squared plus y squared equals 100, if you take the square root of 100, that's going to give you the radius, so it's 10. If they tell you that you have a circle with a center at 0, 0, and the radius is 6, if I want my equation, I'm just going to do the opposite, which is raise 6 to the power of 2, so that I get x squared plus y squared equals 36. Now, based off our observations, we can tell that our equation is x squared plus y squared, because that's how they always started, equals our radius to the power of 2. Now we can verify that using Pythagorean theorem. If I have my center right here, and I extend a line to any point on my circle, okay, and create a right triangle from that, so that I have an x value here and a y value here, and my radius as my hypotenuse, I now have this right triangle, and I can apply Pythagorean theorem. X squared plus y squared equals r squared. Okay, let's try a few examples and practice this formula. The point 52 lies on the circumference of a circle with center 0, 0. Use the formula to determine the equation of the circle. We know the formula always has x squared plus y squared. All we really need is the radius. But when you're given a coordinate that's on that circle, you're given an x and y coordinate. So let's plug that into our formula and just solve for the radius, or the radius squared, because ultimately that's what we need for our equation. So 5 squared plus 2 squared equals our radius squared. So we have 25 plus 4 equals the radius squared, and 25 plus 4 is 29. Now if I wanted to find the radius, I can square root both sides, and I can tell you that the radius of this circle is the square root of 29. But because you're just asking us for the formula, we can conclude that the formula of this circle is x squared plus y squared equals r squared, which in this case is 29. Now I want to do a little side note. If I have the point 3, 4, let's say, if I want to know if this point is inside, outside, or on the circle, I'm going to apply that exact same formula. I'm pretty much going to ask myself, what's the equation of a circle that has the point 3, 4 on it? And then I'm going to compare that radius squared with this 29 and see if it's larger, if it's smaller, or if it's the exact same. So I'm going to do 3 squared plus 4 squared equals r squared, and that's 9 plus 16 equals r squared, which is 25. And now I would be comparing 25 to 29. 25 is less than 29, which would mean this point is inside this original circle that was described to us. Okay, let's determine the equation of each of the following circles for each scenario. Okay, and for all of the circles that we're going to be doing, the center is at 0, 0. If the center was elsewhere, the formula would look slightly different. So for this first one, the center is at 0, 0, and the radius is 16. So I have my equation, x squared plus y squared equals my radius squared. Do not keep it in this form. Simplify it. And 16 squared is equal to 256. And that would be your final answer. Okay, let's do the next one. But now our radius is the square root of 20. So I have x squared plus y squared equals the square root of 20 all to the power of 2. Now here, you can technically go to your calculator, put the square root of 20, and then square it. But I want you guys to remember that a square root and an exponent of 2 are opposite operations, so they actually cancel each other out. So our answer, you can try it in your calculator if you don't believe me, is x squared plus y squared is just equal to 20. The square root and the exponent cancel each other out. Okay, I want you to pause this video right here, and I want you to try C and D on your own because it is similar to that first example we did, and then we'll take it up once you get it. Okay, for C, our point is 6, negative 3, so I do 6 squared plus negative 3 squared equals r squared. Just replace the x and y, and I get 36 plus 9, which is 45. So my radius squared is 45, so my final equation is x squared plus y squared equals 45. Now for D, when you're given a diagram, you just pick a point on the circle. In this case, you can actually read off the radius because it doesn't look like a nice integer or a nice whole number. So I chose 2, 3, that's the one that's given to us. So x is 2, y is 3, and we put that in. 2 squared plus 3 squared is r squared. So your final radius squared should be 13, and that's where we get our final equation from. And that's pretty much it on the equation of a circle.